Hello everyone, welcome back to the channel. In my previous Google Earth Engine tutorials, I have already explained cloud masking, surface reflectance, scaling, how to calculate land surface temperature using Landsat 8 Sentinel-2 level 2 imagery. Since we have already covered those topics in detail, I won't repeat them in this video. So today we're going to calculate another very important drought monitoring index called the temperature condition index, or we can also say it as a TCI. So the temperature condition index is widely used to evaluate temperature related vegetation stress and is one of the key components used in a drought assessment. Later we will combine VCI and TCI to calculate vegetation health index, which provide a more comprehensive picture of drought conditions. So by the end of this tutorial, you will learn uh, what the temperature condition index is, why is it important, many more others, how to visualize the results, and finally how to export the TCI maps as a GeoTIFF and use it in other softwares uh, like ArcPro and QGIS. So before writing any code, let's understand what TCI is. So here is the TCI of Bangladesh Dhaka region, and the temperature condition is a drought indicator derived from the land surface temperature. It measures how hot or cool the land surface is compared to its historical temperature range. So unlike LST, which simply provide the actual surface temperature, TCI normalizes those temperature into a scale from 0 to 100, making it easier to compare temperature stress across different locations and time periods. So generally, low TCI values indicate high temperature and greater heat stress, and high values indicate cooler surfaces temperature and more favorable environmental conditions. So the temperature condition index also have a formula. We will explain it here in the code. And now let's jump into the code. So the script begin with our pre-processing function. So the function here is it. And as mentioned earlier, we have already discussed cloud masking and Landsat pre-processing in previous tutorials. So this function performs two main tasks. First, it removes the cloud and the cloud shadows using this band. And then we have QA red set band that will remove radiometrically saturated pixels using this band. After cleaning the image, we calculate land surface temperature. So here we have calculated land surface temperature. So in the image, we have selected ST band, band 10 for Landsat 8 collection to level 2 data. Band ST band uh, 10 contain the land surface temperature information. However, these values are stored as a scale integer, so they must be converted into actual temperature values. So first we multiply it with this value, and then we add the offset, that is 149.0. This converts the stored digital numbers into temperature values expressed in kelvins. And then we have finally rename it as a new band as LST before adding it back to the image. Now every Landsat image contains a land surface temperature band named as a LST. Okay, so now we have now we load the Landsat 8 collection to level 2 dataset. So we limit the collection to our just region of interest and select all the images acquired between January 2021 to 2020 to 12 months December. And then we have dot map mask LH9SR. It applies our pre-processing function to every image. At this point, we have a collection of a clean Landsat images, each containing an LST band. And then we calculate the minimum and minimum land surface temperature. Now we determine the lowest temperature observed during the study period. So we have created variables minimum LST and maximum LST. So the reducer dot minimum is the function examine every image and identifies a minimum land surface temperature for every pixel location. So the result is a new image representing it the historical minimum temperature. Similarly, we calculate the maximum temperature. This produce another image representing the highest land surface temperature recorded during the study period. So these two images, minimum and maximum LST, are essential for calculating the temperature condition index. Now we calculate TCI. Here we have calculated TCI and we have equation for that. Inside the function, we apply the TCI equation. First, we have this, the max LST dot subtract image dot select LST. So subtract the current temperature from the historical maximum temperature. Then we have dot divide max LST dot subtract minimum LST. This divide by the historical temperature ranges. And finally, we have multiplied it with 100 to get the TCI. It converts the result into a percentage scale ranging from 0 to 100. So remember that we have calculated LST and DVI in the form of points, like it would be from -1 to +1. But for the VCI, but for the TCI, we're going to calculate it from 0 to 100 scale. The output is renamed it as TCI and added as a new band to each image. The process is automatically repeated for every Landsat image in the collection. Okay, so now we have calculated the median. Like we have a variable TCI image, that TCI collection dot select TCI median dot clip roy. The median function combine all the TCI images and calculate the median value for each pixel. This helps reduce the influence of extreme values and produces a stable representation of temperature condition across the study area. So finally, the images is clipped to the region of interest. So then we have a visualization parameters. Now we will display the results. We have map.add layer TCI image. Okay, so next we display the results. Map.add layer TCI image. So the visualization uses a range from 0 to 100 and applies a color palette. So in this example, we have used blue, yellow, and red. Blue represent higher TCI values, indicating cooler surfaces temperature and lower heat stress. Yellow represent intermediate condition and red represent lower TCI values indicating hotter surfaces and greater temperature stress. So after running the script, the temperature condition index map will appear into the map in the Google Earth region. So we can see the blue areas over here. So these represent the higher TCI values that indicate the cooler surface temperature and the lower heat stress. So these are some of the uh, land where the temperature could be good. Uh, Exporting the TCI into the drive, we have a function for that. So in this export, we have used a export.image to drive operation. It's a built-in operation in Google Earth Engine. Then we have used the image that specifies the TCI raster. Then we have a description that provides the export task name. And we have a scale that represents the preserves the Landsat's 30-meter spatial resolution. Then we have region that define the export boundary. We have file format. GeoTIFF saves the output as a GeoTIFF file. And then max pixel is increased to support exporting large study areas. So after the export finishes, the GeoTIFF file will be available in your Google Drive, ready to use. ArcGIS Pro, QGIS, or any other software you're going to use, you can plot it over here. So in the next tutorial, we will calculate the vegetation health index by combining VCI and the TCI we have calculated in the previous tutorial and today. That gives us a more complete assessment of vegetation health and drought condition. So if you found this tutorial helpful, please like the video, subscribe to the channel, and turn on the notification bell so you don't miss the upcoming Google Earth Engine tutorials. So thank you for watching. I'll see you in the next video. Bye.